So far, we've only seen a visualization which draws a line on our Matplotlib graph. Let's see how we can work with lines as well as markers. We start off with the same sine curve that we worked with earlier. We'll generate some random data for the x-axis between 0 and 10, 50 points, and then we'll plot x and the sine value of x. After plotting our sine curve, we've called the plot.show function. This is not needed if you're running in interactive mode. I've left it just in there in case we have people working on non-interactive mode. And here is our single sine wave plotted with the default Matplotlib colors. Now the same plot can be used for multiple visualizations. You can add multiple curves by specifying them both. We invoke the pyplot plot function, and for the same x values, we add the sine curve as well as the cos curve here, and both of them will be drawn on the same graph. When you call the plot function twice with different values, Matplotlib is smart enough to know that this represents a different data set, which is why it plots it in different colors, and the legend is updated accordingly. Matplotlib has picked the colors from the default palette that it has. We've assigned a title to this plot as well. Playing with plots is our title. Now let's customize the colors in which we view this visualization. We can specify the colors in different formats, including hex codes. Here we've used two different formats that are the most commonly used. Our sine curve will be in the green color. We've specified the full name of the color here, and the cosine curve will be in the magenta color. We use a short form, M is for magenta. The curve is set up as you've specified, and the legend is also updated accordingly. Let's use the NumPy library to generate some random numbers here. We'll generate 20 random numbers and plot them using Matplotlib. We simply pass in the random array. These form the y coordinates. The x coordinates will be equal to the index of the corresponding y coordinates. There is no particular order to the random numbers that we've generated. Matplotlib has plotted the data points and connected all of them using a green line. The green color was what we specified. We can customize the line that connects our data points by specifying the line style attribute. Line style is equal to colon is the notation for a dotted line. The default line, as we saw earlier, was solid. Line style is equal to colon will draw a dotted line connecting our data points. The dotted line is also in green. You can draw a dashed line if you specify line style is equal to dash dash. That is the notation for a dash line. You can customize the thickness of each line drawn by specifying the line width input argument. Here line width is equal to 3, which means the line drawn is thicker than the default. The default line width is set to 1. Now, so far, our focus has been on the line connecting the data points, but what if the data points are the ones that are significant? We want to highlight them in some way. We can do this by using the marker attribute. Marker is equal to D. We'll use the diamond shaped marker for each of our data points. Each diamond shaped marker in our plot is also green in color. The color attribute applies to both the line as well as the markers that we draw. We can make our markers more prominent by specifying a size for the marker using the marker size input argument. The default size of the marker is 6. A marker size of 10 makes them display more prominently on our plot. The marker size input argument increases the width as well as the height of the diamonds. If you only want to plot the markers and not the connecting line, you can specify line style is equal to none. This will get rid of the line entirely and you're left with only the markers. So far, we've only used the plot function from pyplot. The pyplot module also offers the scatter function, allowing you to plot scatter plots. Scatter plots are used to model bivariate distributions or relationships between two variables, one on the x-axis and one on the y-axis. When you use the scatter function from pyplot, the markers themselves are what are plotted by default. There is no connecting line.